Hello everyone, welcome to Jack of Engineering YouTube channel. So today we are going to learn the iron carbon diagram in very short way. So here you can see that the iron carbon diagram picture I have taken from the YouTube or Google source. So it represents the temperature which varies to carbon percent in iron. Okay, in x-axis the carbon percent it shows it belongs to 0 to 6.67%, and the 6.67% is called cementite phase. Okay, and the y-axis shows the temperature. In left side you can see there is the degree centigrade it is showing in, and at the right side of the iron carbon diagram it shows the degree Fahrenheit as shown. So iron carbon diagram basically shows that phase transformation variation according to their temperature, according to temperature heating and the iron carbon percentage. So if the carbon belongs to 0 to 2%, then it is called steel, and above 2% carbon, that's called the cast iron. Okay, so here in our iron carbon diagram you can see there are different phases are like austenite, cementite, ferrite, alpha ferrite, and also liquid phases. There are also different phases that can form according to the temperature variation. Okay, there are major stages you have to remember. There is the three reactions. Okay, the first reaction is the peritectic reaction, which is formed in 1493 degrees centigrade. There you can see the liquid and delta ferrite merge, and delta ferrite merge is there, and it creates the austenite phase. Okay, the austenite phase, that's called the peritectic reaction. And the next reaction is Eutectic reaction, which is the more and relevant reaction. You have to remember this reaction. This reaction happens in that portion of 1147 degree temperature. Okay, here you can see the liquid phase. The liquid phase is transformed to this. I can write it there. Liquid phase transformed to here you can see austenite is there, austenite plus here from right side we can take Fe-Fe₃C. So which phase it is happens? It is called the Ledeburite phase. After liquid transforms to Ledeburite, that's called the Eutectic reaction. Okay, you can learn it by in easy steps. And the third reaction is Eutectoid reaction, which happens in 723 degrees centigrade. Here you can see the austenite phase is present there. The austenite, you can see there is austenite present. The austenite is transformed to alpha plus Fe₃C. Here the phase is alpha, which is ferrite, plus Fe₃C on the right side, which is called the pearlite phase, because you already know that the pearlite structure is look like the lamellar orientation of alpha ferrite and cementite. That's called the Eutectoid reaction. Here the major three reactions you can get from the iron carbon diagram. And iron carbon diagram shows also the pearlite plus Ledeburite phase. Using different temperature and different carbon percentage, you can change the phase diagram according to this diagram. So in industries, the application of that iron carbon phase diagram is very high. Okay, if you have to if you have to learn the blast furnace operation, you have to must learn the iron carbon diagram. They are mostly use this diagram to create different amount of grades and to observe the microstructure of the different phases. Okay, to observe the different phases also there. Liquid phase also different temperature. Okay, and here I can also tell you that the alpha ferrite is the most softest phase there, and the most because the carbon percentage is low, like 0%, 0 to 0.2% carbon is present. So in your mind you can think that if the carbon percentage is high, then you can say that the grains, the size are getting, the strength are getting harder, but this not happens. It is because of very factors like Hall page relationship, the grain orientation. If the grains are smaller in size, finer in size, that would be very hard strength material. The cementite have also 6.67 carbon percentages. The cementite phase is the hardest phase in Rockwell hardness tester. You can find 90 to 92 or above hardness you can find in the cementite phase. And the austenite phase is non-metallic phase, and also there is different structure is also present over there. Thus today's lecture is over. So just learn those three reactions properly, then overall iron carbon diagram you can cover in that way. Okay, bye, and subscribe to Jack of Engineering YouTube channel for more interesting topics. Jack of Engineering.